Starting torque decreases quickly as bearing lubrication films are established, but the need for torque increases with increasing speed due to the power required to drive the axial flow compressor. When the gas turbine startup sequence is initiated, the overrunning clutch of the hydraulic ratchet mechanism clamps onto the output shaft of the torque converter. Successive forward strokes of the ratchet rotate the output shaft in a series of turns, each measuring about 40 degrees. This provides sufficient torque to overcome the static friction in the turbine and to break away the turbine rotor. The starting motor is then turned on, and the torque converter fills with lube oil. Power is transferred from the motor-driven impeller to the turbine wheels and the output shaft of the torque converter. This forces the gas turbine rotor to begin turning at a few RPM. The starting system accelerates the turbine to purge speed. The unit remains at purge speed long enough to exchange 3 to 5 times the exhaust system's volume of air. This eliminates the danger of explosion from any combustible gas mixtures that may have been inside the turbine. After the purge cycle is completed, the torque converter is drained and the turbine coasts to an appropriate firing speed. Draining the torque converter hydraulically disengages the turbine wheels from the impeller. Thus, there is no need for a mechanical clutch. The torque converter is refilled with lube oil during the firing sequence. The adjustable guide vanes are opened fully, allowing the torque converter to develop its maximum speed and torque. In this way, the starting system assists the gas turbine in accelerating to a self-sustaining speed. At about 60 to 80% of rated speed, depending on unit design and application, the gas turbine will overrun the starting system. The torque converter is drained again, disengaging the electric starting motor from the rest of the system. The electric starting motor continues to run for a short cool-down period, then shuts down. When the gas turbine rotor is stationary and the hydraulic ratchet mechanism is activated, the clamping pieces of the overrunning clutch are wedged between the outer ring of the hydraulic ratchet mechanism and an inner ring installed on the torque converter's output shaft. A forward stroke of the hydraulic ratchet applies a direct churning force to the output shaft to break away the turbine rotor. During the return stroke, the outer ring of the hydraulic ratchet mechanism freewheels past the overrunning clutch. When the gas turbine rotor begins turning at a very low speed, centrifugal force causes the clamping pieces of the overrunning clutch to lift off of the inner and outer rings. During steady-state conditions, the overrunning clutch continues to operate without contact and is virtually wear-free. During a normal startup procedure, the lead operator selects Auto and Execute on the operator interface of the turbine control panel. The turbine control and protection system starts the necessary auxiliary equipment, including the auxiliary lube oil pump. Lube oil is required for, among other things, proper operation of the torque converter. When lube oil pressure is established, the turbine control and protection system starts the auxiliary hydraulic supply pump. Hydraulic oil is required to operate the hydraulic ratchet mechanism. Once hydraulic oil pressure is established, the control system continuously cycles the hydraulic ratchet mechanism by means of 20 HR-1. 20 HR-1 is energized to initiate a forward stroke. 63 HR-1 signals the end of the forward stroke, and 20 HR-1 is de-energized to begin the return stroke. This sequence is repeated as necessary to break away the gas turbine rotor. At the appropriate moment in the startup sequence, the control system turns on the starting motor, 88 CR-1. The control system also energizes the torque converter fill-drain solenoid valve, 20 TU-1, after a delay of 5 seconds to allow the starting motor to achieve operating speed. When energized, 20 TU-1 allows the torque converter to fill with lube oil. The motor-driven impeller of the torque converter accelerates the lube oil in the converter casing, which transfers energy from the impeller to the turbine wheels and output shaft of the torque converter. The resultant transmission of torque increases the speed of the gas turbine rotor. Once the control system senses the increase in turbine speed, the hydraulic ratchet mechanism is deactivated. During the purge cycle, several changes of air are allowed to pass through the turbine. This removes any combustible mixtures of fuel and air that might otherwise ignite prior to the firing sequence. Once the purge cycle is complete, the control system de-energizes 20 Tu-1 and the torque converter is drained. This hydraulically disengages the electric motor starting system from the gas turbine, and the turbine coasts to a lower speed in preparation for firing. The control system signals the torque adjuster drive motor to move the adjustable guide vanes into the firing speed position. This is controlled by limit switch 33TM-8. After a warm-up cycle, fuel flow to the gas turbine is gradually increased. The adjustable guide vanes in the torque converter are turned again, this time to the acceleration limit established by 33TM-7. This allows the torque converter to assist the gas turbine in accelerating to a self-sustaining speed. When the gas turbine achieves a self-sustaining speed, 20 Tu-1 is de-energized and the torque converter is drained. This disengages the torque converter from the electric starting motor. The electric starting motor runs unloaded for 15 minutes to cool down and then shuts off. During steady-state operation of the gas turbine, the output shaft of the torque converter remains coupled to the accessory drive gear. The accessory drive gear and its auxiliary devices are now being driven by the gas turbine. Normally, turbine shutdown is initiated when the lead operator selects stop and execute on the operator interface of the turbine control panel. The shutdown sequence will proceed automatically through generator unloading, turbine speed reduction, fuel shutoff, and initiation of the cool-down cycle as the unit comes to rest. During the cool-down cycle, the rotor of the gas turbine is turned to provide uniform cooling. This prevents rotor bowing, resultant rubbing and imbalance, and related damage that might otherwise occur when subsequent starts are attempted without sufficient cooling. Once the turbine speed has dropped to 0%, the control system energizes 20 HR-1. Hydraulic oil is admitted to the two forward stroke pistons of the hydraulic ratchet mechanism. The pistons drive the outer wheel of the hydraulic ratchet. The clamping pieces of the overrunning clutch clamp onto the output shaft of the torque converter and turn the rotor of the gas turbine about 40 degrees in 30 seconds. Pressure switch 63 HR-1 signals the end of the forward stroke. At the end of the forward stroke, 20 HR-1 is de-energized. Hydraulic oil is fed to the return stroke piston, and the overrunning clutch disengages as the hydraulic ratchet is reset. The return stroke also lasts about 30 seconds. Pressure switch 63 HR-2 signals the end of the return stroke. The torque converter is refilled with lube oil and the starting system accelerates the gas turbine to firing speed. firing speed creates the optimum airflow through the combustion chambers to ensure ignition and flame propagation. At this point, fuel is admitted to the combustion chambers and is ignited.